let's go.
We're the Carbon Futurescape team, and we'll be predicting carbon emissions using population economic metrics. I want to start with the problem. Greenhouse gases accelerate and intensify the climate crisis. One significant portion of the greenhouse gases is carbon dioxide, with about 64.3%. That is what we'll be focusing on. But where do these carbon emissions come from? They come from our everyday activities like burning fossil fuels, deforestation, transportation, and emissions from heating and cooling. But climate change caused due to carbon emissions disproportionately impacts poorest people in the poorest country. It reduces crop, decreases water availability, and causes extreme events. But at the same time, these developing countries need carbon-intensive activities to grow and develop their economies. So our research will be answering how to decide equitable and allowable carbon dioxide emission targets across different countries. And we'll be answering this using a prediction model.
Right now, we have two data sets. Like our main data set is from the World Development Indicators, and it includes the national, regional, and global estimate. And for our supplementary data set, it includes the matrix for the use and the gender-specific unemployment rates. As for our data selection process, we just select 266 countries first, and then we select 22 variables available. And then we define the year from 2000 to 2023. We got the hypothesize impact on CO2 emissions. And as for the 22 variables, we dropped the 7 first because they have too many missing values, and then we add another 2 variables. Then we do the imputing the missing values to predict the CO2 emissions.
And we talk about the model. First, we convert the CO2 emission data into a binary format to apply logistic regression model. For larger percent of our outlier, we look like the show distribution of on the right. We decided to use the median about 14 million ton as a cutoff value. So in our binary mapping, value greater than this one are mapping to 1 and the other is a mapping to a 0. Next, thank you. And then we find the models accuracy about 50%, so there are no improvement over baseline accuracy. So this is likely due to very predictor scale. So we move to the next step about the normalize the data. And this one is we continue to try linear regression model. We finally select one because of future engineering based on a VIF. Next, thank you. And we find the we finally find the current co-predictor identify include the most possibility is impact CO2 emission, such as GDP and the total population, will current level of healthcare and expenditure negatively impact CO2 emission. So these insights are essential for understand. Yeah.
There are 2 reasons why we use random forest regressor, because first, it's robust to noise, and it can help us like estimating the importance of each variables. As you can see on the model evaluation, like the two model is performing better than the baseline models. And we also try to attempt to remove the low importance features to reduce the overfitting and enhance interpretability.
We also tried decision tree. Our first attempt basically focused on 70% of training data set and 30% testing. We did hyperparameter tuning, and our R-square came out to be 1, which was surprising, and we think it might be an overfit. We're still trying to continuously improve our mean squared error. And also, for now, our feature importance tells us that land area with about 79.17% is the most important. Just a quick comparison of the model. I want to highlight that logistic regression was easy to implement, but had a lot of limited applications and oversimplified our solution. For linear regression, it had a couple of potential applications, but it also assumes linear relationships. So we are focusing on random forest regressor, as it has a better interpretability to a newer model, but we're worried about the computational intensity that we will understand as we wrap up this project. In terms of our impact, we want to diversify our goal and include variables representing various demographics. Our challenge is how will it translate to countries missing? And this is something that you'll find out in our project. It has a lot of real world implications. I want to highlight 2 that it will help us in equitable and realistic goal setting of what are the actual values that CO2 emission reduction goals should be set at. It'll help us identify high impact sectors and also policy support. And lastly, we for now think that land area and total population are the most influential predictors. There's a strong correlation between economic developments and carbon emissions. And lastly, that healthcare expenditure surprisingly has a negative impact. stay tuned to find out what our project